everyone. We have started with the lesson linear equation in two variables. In that we have studied the standard form of the linear equation and simultaneous equation, how to solve by two methods, that is by eliminating method and by substitution method. Then again next we have studied the graphical representation of the simultaneous equation. Now today we are going to study about the determinant. If A, B, C, D are numbers, then its these are the numbers. Its representation will be A into D minus B into C. It can be represented in determinant as AB and CD. This type of representation is called as the determinant. Now its two rows AB and CD are the two rows and AC and BD are the two columns. So this determinant is of the degree 2. Now we will learn how to simplify this determinant. We can give the names to this determinant in the capital letters, using capital letters A, B, C, D. Any capital letters A, B, C, D, E. Okay, so let's take one example to solve the determinant. 2, 3, 4, 6. Now how to simplify this determinant? So n is equal to 2 into 6 minus 4 multiplied by 3. This n is equal to 12 minus 12. So therefore n is equal to 0. Now you have to simplify the determinant in this way. Now let's take one more example. 2 root 3 and 9. 2 root 3. Now we'll simplify. Let's give the name to this determinant as B. So B is equal to 2 root 3 into 2 root 3 minus 9 into 2. So this simplification is 4 3s are 12 minus 9 2s are 18. Okay, 18 minus 12 is equal to minus 6. So B is equal to, therefore the value of determinant B is equal to minus 6. So now in this way we have to solve the exercise 1.3 of determinant in that question number 1. Now we will study after this how to simplify the simultaneous equation by the determinant method. Let's take one example. N is equal to 5, 7, 3, 9. Now we will find the value of the determinant n, which will be equal to 5 into 9 minus 3 into 7. So n will be equal to 45 minus 21. So therefore value of determinant n is equal to 24. Okay. Now using determinant method, simultaneous equation can be solved in an easy way and in a less space. So this method is known as determinant method. Now this method was first given by Swiss mathematician Gabriel Kramers. So this method is also known as Kramers method. Now to use this method to find this determinant to solve it by Kramers rule, we will see. first we have to write the linear equations. Now see, to solve these equations by Cramer's rules, linear equation a1x plus b1y is equal to c1 and a2x plus b2y is equal to c2. Determinant method. Cramer's rule. Okay. Now see, in this equation, in these two equations, x and y are the variables, and a1, b1, c1, a2, b2 and c2 are the real numbers. Now we will give this equation name as a1x plus b1y is equal to c1 as 1 and a2x plus b2y is equal to c2 as equation 2. Now we will multiply equation 1 by b1. Multiplying equation 1 by b1. Equation will be a1 b1x plus b1, we will multiply it by b2. Okay, a1 b2 plus b1 b2 y is equal to c1 b2. We will give this equation as 3 and equation 2 by b1. So it will be a2 b1x plus b2 b1y is equal to c2 b1. This will be equation 4. Now subtract equation 3 from 4. Subtracting equation 3 from 4. So it will be a1 b2 x plus b1 b2 y is equal to c1 b2. a2 b1 x plus b2 b1 y is equal to c2 b1 minus, now see this subtracting, this will get cancelled. It will remain a1 b2 minus a2 b1 and x will take common, c1 b2 minus c2 b1. Therefore x will be equal to c1 b2 minus c2 b1 upon a1 b2 minus a2 b1. Now see, this can be written as c1 c2 b1 b2. In determinant form, this can be written as this, and here it can be written as a1 a2 and b1 b2. Means this can be written as in determinant as this c1 c2 b1 b2 a1 a2 and b1 b2. Similarly, we can find it for y. Same way we can find it for y. Y is equal to, y will be equal to a1 C2 minus A2 C2 upon A1 B2 minus A2 B1, which will be equal to A1 A2, it is here C1 C2 upon A1 A2 B1 B2. In this way we can find out. So to easy to remember, the Cramer's rule is what? D will be equal to what? A1 A2 B1 B2, and x dx will be equal to C1 C2 D1 B2, and dy will be equal to A1 A2 and C1 C2. Now these are the values of d, dx and dy. Using this we can find out the value of x. X will be equal to x, therefore x will be equal to dx upon d, and y will be equal to dy upon d. Means see what we have studied here by solving simultaneous equation. We have got x is equal to what? C1 C2 B1 B2. We got here C1 C2 B1 B2, that is equal to dx, and this A1 A2 B1 B2 is d. Okay, so directly we can get x value as dx by d, and y value we will get dy by d directly. So this method will be easy to find out the value of x and y, means to solve simultaneous equation. So let's take one example to solve this x and y value by using Cramer's rule. Let's take one example by Cramer's rule. Now first see this equation I have written 4x plus 3y minus 4 equal to 0. Is it in standard form? No. So first we have to write it in standard form. So the equation will be equal to 4x plus 3y is equal to 4. The second equation will be equal to 6x plus 5y is equal to 8. Now after writing this equation in standard form, now we can use the Cramer's rule. Okay, so Cramer's rule, what does it tell? D is equal to what? D is equal to A1 A2 B1 B2. Now this equation you have to compare with the standard form. A1x plus B1y is equal to C1. A2x plus B2y is equal to C2. So here A1 is 4 and B1 is 3 and C1 is 4. Okay, so D's value will be equal to what? D is equal to 4, 6, 3, 5. Now we have to find the value of D. D will be equal to 4 into 5 minus 6 into 3. Now 4 5s are 20 and 6 3s are 18. So D is equal to, therefore D is equal to 2. D will be equal to 2. Now we will find value of dx. Now dx means equal to what? Dx is equal to C1 C2 B1 B2. Now C1 means what? Dx is equal to, C1 means what? This equation you have to see. C1 is 4 and C2 is 8 and B1 is 3 and B2 is 5. Okay, so therefore dx value will be equal to what? 4 into 5 minus 8 3s are 24. 4. So dx will be equal to what? 20 minus 24. So dx is equal to what? Minus 4. Now we got dx value. Now what we want to find out? We have to find out the value of dy. dy is equal to what? dy is equal to a1, a2 and c1, c2. Okay. Then dy is equal to a1. a1 is 4 and a2 is 6. c1 is 4 and 8. Now here all the terms are positive. So here all signs are positive. Now see, dy is equal to what? 4 8s are. 4 into 8 minus 6 into 4. So 4 8s are 32 minus 24. So dy will be equal to, dy is equal to 8. Okay. dy is equal to, dy is 8. Now we want to find the value of x. So x is equal to what? X is equal to dx upon d. So x is equal to, dx is minus 4, d is 2. So x is equal to minus 2. Therefore x is equal to minus 2. Therefore x is equal to minus 2. Now we have to find out value of y. Y is equal to what? dy by d. Now y is equal to, dy is 8 upon 2. 8 upon 2. So therefore y is equal to 4. Okay. So here we got the value of x as minus 2 and y as 4. So same way we can solve the for more examples by using Cramer's rule. Now see, your work is to solve exercise 1.3 completely. This is today's homework. And